Okay, so in this video, we are going to take a look at two examples of chi-square test. So we have one chi-square goodness fit test, and we have the also the effect size. We're not exactly going to do effect size, but we are going to look at the chi-square test of independence. So here's the first problem. Let's see, here's the situation. So cats are being finicky about their food, and research arranged 5 brands of the leading cat food products, of which reported to be cat preferred. For the analysis, each of the 25 cats were presented with all 5 brands at the same time, and the preferences were determined by the brand that the cat ate. The tabular results are in the following table. So you have A, B, C, D, E, 5 brands, and this is observed 7, 2, 4, 10, and 2. And under the null hypothesis, of course, under the null hypothesis, there's no difference in the preference. So out of 25, you should expect to see 5. For the 5 for brand A, 5 brand B, 5 brand C, and etc. So these are the expected frequencies. Right, so that's the observed, this is the data, and these are the ones, the expected frequencies under the null hypothesis, when there's the null hypothesis, in this case, says there's no difference, there's no preference. And so we basically go through step number 1 is to state the null hypothesis and the alternative hypothesis. And step number 2, we want to decide on alpha level. So we're going to use alpha equals 0.05. And let's see, then next step is to test the, to figure out the test statistic. And the test statistic in this case is the, let me see, the equation is chi-square equals sigma observed minus expected divided by expected. So O minus E observed minus expected is, let me see, let me grab a pen. So this is 2, right? And 2 minus 5, negative 3. So this is actually called residual. Right? Observed minus expected. To what extent the observed frequency is different from what is expected. So 4 minus 5 equals negative 1. 10 minus 5, expected, the residual equals 5. And 2 minus 5, negative 3. Next step, we'll take the square of the residual. So 4, 9, negative 1 squared, positive 1. 5 squared, 25. Negative 3 squared equals 9. Right? And the last step is we take this squared portion divided by expected. So 4 divided by expected is 5. Right? And 9 divided by 5. 1 divided by 5, 25 divided by 5, and finally 9 divided by 5. 9 divided by 5. And sigma just means we are going to add these together. Now, if you add them together, the number that I got equals 9.60. Okay, so the chi-square test statistic equals 9.60. Now, next question, how many degrees of freedoms do we have? So, how many categories? We have 5 categories. So, degree of freedom equals k minus 1. The number of categories minus 1, so 5 minus 1 equals 4. We have 4 degrees of freedom for the test. So next, what is the critical value for chi-square with 4 degrees of freedom? And let me see, that is, actually this is a different problem. So we need to figure out the chi-square. So we're going to keep that. And let's take a look at the chi-square distribution. So 4 degrees of freedom critical value of chi-square equals 9.488. So we just 9.488. And so that's the critical value. Any chi-square that's greater than 9.6 means it's statistically significant. So our chi-square actually is somewhere over here. So we barely made it, right? And we can also type in the chi-square that we calculated. So 9.6 with 4 degrees of freedom, P equals 0.048. Okay, so P equals, according to the chi-square table, sorry, not to that, escape, and I just need a pen. So P equals 0.048, which is borderline, but we made it. So less than alpha level, 0.05. So we can actually reject the null hypothesis that the cats have no preference. In fact, according to our test, cat does have a preference. It looks like D and A are the more preferred brand compared to B or E. Those are the least preferred brand. So that is a test of, that is the first problem. That's an example of a chi-square goodness of fit test. Now let's take a look at the second problem. We have two variables. One is country. It's a categorical variable with United States and Canada, so two categories. So k minus 1 equals 1. So we have 1 degree of freedom for country. The other variable is the type of professionals, mental health professionals. We have psychiatrists, we have nurses, psychologists, and social workers. So j minus 1, 4 minus 1 equals 3. Right? So the degree of freedom in this case equals 1 times 3 equals 3. So for the test, we have 3 degrees of freedom. 1 times 3 equals 3. So we are going to have 3 degrees of freedom for this test. And step number 1, hypothesis. So what is a null hypothesis? So null hypothesis always says no relationship, independent. Okay, so the null hypothesis says the country's access to mental health services in the United States and Canada is independent of the country. So country have nothing to do with access to the mental health, to the type of mental health professionals that we have. The alternative hypothesis would say, no, the two variables are related. Next step, alpha level for the test. We're going to use alpha equals 0.05. Degree of freedom, we already calculated the degree of freedom. Equals 4 minus 1 times 2 minus 1 equals 3. So we have 3 degrees of freedom. Next thing we are going to do, of course, is to identify the critical value for chi-square test with 3 degrees of freedom. And so again, we need to go to the chi-square distribution. So we have 3 degrees of freedom and the critical value. So P equals 0.05 and the chi-square critical value equals 7.82. 7.82. So if we calculate the chi-square greater than 7.815 or 8.2, then it will be in the region of rejection. Okay, so let's go back to our data and finish our calculation. Okay, so this is the data kind of rearranged in the table. So these are the observed numbers. So next thing that we are going to do is to calculate the expected frequency. And because expected frequency equals row total times column total divided by grand total, so we are going to need the row total first. So let's do that. So 11 plus 15 equals 26. 69 add 4, 73. And 30 plus 49, we should have 79. And 145 plus 60, that would be 205, right? Of course, if we add them together, 25 plus 73, 79, 205, 3, 8, 383. Okay, is the grand total. Next, let's calculate the column total. So 5 and 10, 105. And here we do the same thing, add these numbers together. So it equals 278. And of course, if we add 105 plus 278, that is also 383. Next thing we are going to do is to calculate the expected frequency under the null hypothesis. So expected frequency equals row total. So for this one, it should equal 105 times row total, which is 26, right? Divided by the grand total, 383. And that should equal 7.1. I did the calculation ahead of time, so I know the answer is 7.1. And how do we do what is expected frequency for access to nurse in United States under the null hypothesis? Well, that's 73 times 105 divided by 383. And the answer is 20. And I'm just going to give you the numbers for this. This is 21.7. And that is 56.2. I do one more. So how about what is the expected frequency for this cell? 278 times 26 divided by 383. And we should have 18.9. Okay, I'll leave the next 3 cells to you, so you can finish the calculation for these 3 cells. And once we figured out all the expected frequencies, the next step is to subtract observed minus expected. So 11 minus 7.1, take the square divided by 7.1. And then 15 minus 18.9 squared divided by 18.9. And we go through each one of these 8 cells and add them together. The sum is the chi-square. Okay, so we just use this equation, and we can give you a few of those numbers. You can finish the rest. So this cell, it equals 2.10. For this cell, it equals 0.794. I'll give you one more. This cell, it equals 12.81. And etc. So you can finish the rest of the calculation. And the sum, it means you add all these 8 together. Chi-square should equal, according to my calculation, you should verify that, equals 25.33. Now, does anybody remember the critical value of chi-square? Somewhat looks like this, right? So chi-square critical value is 7 point something. So that's 7 point something. And our chi-square equals 25.33. So this is way over here, right? This is way over here. So our conclusion is that we would reject the null hypothesis and conclude that the access to the professionals, for the mental health professionals, is different for United States and Canada. In other words, country and access to mental health professionals is the two variables are related. Okay, so yeah, so no, this is not right. We need 3 degrees of freedom. So we're going to keep that, and let's go to the website. 3, yes. So our calculated chi-square equals 25.33. So p-value equals 0. Now, not exactly 0, but it's less than 0.001. Okay, so in this case, we would reject the null hypothesis with p-value less than 0.001. So that finishes the 2 examples, the chi-square tests, and this is part of the activity 14-1. So finish the calculation and finish all the details and get it submitted and for the activity credit. And once you've done that, let's see, I'm going to post the answer keys. So it's a good idea to compare your calculation with the answer keys and make sure that everything is done correctly. Okay, so this is basically the last lesson and the last learning activity for this entire semester. So we are basically done. Okay, this is the end of this video. Thank you.